So hello everyone. You might be a little bit overwhelmed with these amazing technologies that you have seen today. We are going to talk about physics, but I will go easy on you first. So who in the room likes cake by raise of hands? Great. Who has ever tried to bake a cake, at least once in your lifetime? All right. So let's pretend that we would like to have the perfect cake. You would like it to be delicious, you would like it to be healthy, you would like it to be beautiful. And let's think that in order to get to this perfect cake, you might need to try, let's say, 99 times until you get to that perfect, beautiful, single cake. That will mean that 99 of those attempts will go directly to the trash can, with a corresponding cost and time and emissions to the environment, just to get to that single cake.
How about changing the ingredient sector?
That will mean to do this all over again, and another 100 cakes will go to the trash can. Now, instead of thinking about a cake, let's just think about trying to have the perfect paint formulation, or maybe the right mayonnaise recipe, or the eco-friendly plastic bottle that we are looking for, or the right therapeutic vaccine, even the right cosmetic, or that special alloy for a semiconductor. All of these materials, and I could go on and on, are known as amorphous materials, and these represent a challenge. If we would need to find the right combination, we will need to try hundreds, maybe even millions of different combinations until finding that right, perfect one, with the corresponding impact in time, cost, and the huge environmental impact. So this leads us to the question, do we truly understand how material properties work? Why does it take years to launch a vaccine or find that right CO2-free chemical product? The answer may surprise you. Science has not been able to fully explain how this type of materials work at a molecular level, thus resulting in cost and time and emissions. Understanding how these systems interact, how the molecules attract or repel each other, has been a scientific mystery. Simply put, there were no physics equations to explain how this type of systems work, resulting in these long development times. At Monte Caldera, we have solved this scientific challenge. We discovered a first principles physics approach to get to that 100 cake faster.
Using a set of algorithms known as NESCGLE, and which replace the current state-of-the-art of computational physics, we can efficiently predict and hence control the properties of these amorphous materials, streamlining R&D processes across multiple verticals and potentially saving for companies billions of dollars, the same B of business. So, in simple words, our technology, it's like Tony Stark's Jarvis. It allows for the rational design and discovery of new material formulations. Based on our fundamental mathematical discoveries, which combined with physics and chemistry, can advance the speed at which new products hit the market. But very importantly, our Jarvis, our technology, it's not another AI platform, but instead it's powered by our unique and disruptive theoretical approach, the NESCGLE. Hence, we propose a faster, more sustainable, and efficient alternative to otherwise costly traditional methods, such as trial and error experiments or intricate and time-consuming computer simulations. And please remember here the analogy of the cakes. So we expect to reduce the times for R&D processes from the timescale of years to only weeks. Can you imagine that? We created a powerful, collaborative, user-friendly, and scalable interface for the new generation of material modeling tools, based on our theory and which we call the Caldera engine.
The AI materials informatics is estimated at 20 billion, and it is predicted to grow up to 60 billion by 2030. Our Caldera engine is the only solution incorporating first principles physics, and we are expanding these capabilities with AI and machine learning algorithms. Our business model is centered around our NESCGLE proprietary technology with two main revenue streams. One, a highly scalable SaaS platform aimed at enterprise customers with average annual contract values ranging from 60K to 500K. And second, a royalty sharing approach aimed at strategic partners, such as, for example, PPG, which is a Fortune 500 company, and with whom we are already conducting pilots. Market applications for our NESCGLE-based technology are really broad, but we are aiming to creating the highest impact. So we are focusing on the industries that we know can deliver the highest results, from developing safer ingredients to affordable therapeutics to next-generation sustainable materials.
You can imagine what you eat. You can imagine what sanitizes your hands. You can imagine what vaccines you. You can imagine eco-friendly cement.
So ultimately, we see that we will be making 95% of the materials that you see around us in a better, safer, and faster way. We will do this with a team of world-class scientists, 14 PhDs in applied physics, material science, and nanotechnology, and co-authors of the NESCGLE theory, are working upon a 30-year scientific legacy developed and led by Professor Medina Noyola, who happens to be here and happens to be my dad. I'm really glad you're here. I love you, Dad. So for me, it's a personal endeavor to make Monte Caldera reach its full potential. I have over a decade experience in management consulting, and Luis here with me, he has over 6 years working at the German Aerospace Center. And together with leading friends, family, and colleagues, one of those is my sister, who is right here with me as well as an advisor. We are shaping Monte Calderas for the future. Our technology has been recognized by international competitions, and we have the support of leading organizations and companies that have validated our technology. And this is the reason why we are setting the way to prepare Monte Caldera for exponential growth. We have the team, we have the technology, and we have the speed, and we are looking for the right partner to lead the way with us. We already raised $500,000 in pre-seed, and we are looking to raise $5 million in capital, seed capital, to accelerate our product development, grow our scientific team, and establish base operations in Midwest and the Bay Area, and to fuel our growth in 3 key verticals: biotechnology, chemicals, and energy. So if you are focused and want to be interested into how to disrupt the market with this kind of technology, please give us a call. We'll be happy to have a conversation with you.
Please join us in this journey to preserve our scientific legacy, but more importantly, to use it to find the solutions for a more sustainable world.
One equation at a time. Thank you very much.